So we continue with electrolysis and we are on the next one, that is electrolytic dissociation, the term. The process due to which an ionic compound in a fused state or in aqueous solution dissociates into ions by passage of electric current through it is called as electrolytic dissociation. So it's a simple thing that whenever there is any particular compound which is an ionic compound which is already made up of ions, if this particular ionic compound dissociates, or is this ionic compound in a fused state, that is in a molten state, or in aqueous solution, if it is dissociating into its respective ions and then on passage of electricity, is called as electrolytic dissociation. So comparison between electrolytic dissociation and ionization. Now ionization is different from dissociation. Now for dissociation it is necessary that the compound which is there is already ionic in nature. Okay, it's already ionic, it's already Na plus and Cl minus. Not unlike the one of HCl. I mean, if I take in HCl, HCl is a covalent compound. In a covalent compound, and here what will happen is that only when it comes in contact with water, we know we are studying in acids, and when it comes in contact with water, you are getting H plus ions and OH minus ions, H plus ions and Cl minus ions. Okay, so this is going to be, this particular thing is ionization. Okay, that is a covalent compound or a element which was not made up of, a compound which was not made up of ions, when they are going to form into ions due to some kind of a chemical reaction, is called as ionization. Whereas a ionic compound, when it is going to be dissociating, is called as dissociation. So electrolytic dissociation is a process which takes place in electrovalent compounds, where ionization takes place in a covalent compound. Electrolytic dissociation, it involves separation of ions of the ions which are already present in an ionic compound. So when a ionic compound ke andar already the ions are present and then you are dissociating, is called as electrolytic dissociation. Whereas it involves formation of charged ions from the molecules which are not in the ionic state. So that's why HCl in the aqueous form will become H plus and Cl minus. So ionization may also involve atoms changing into ions. So when atoms change into ions, it is also can be considered to be as ionization. So in case of ionization, the original state of that particular compound was covalent, but on coming in contact with water or becoming an aqueous solution of it, it has now become an ion. And in such a condition we call it as ionization. So that's the difference between ionization and dissociation. So let's understand this particular thing in detail. So they are given you in detail the ionization and electrolytic dissociation and ionization over here. So let's understand it. Solid sodium chloride is a non-electrolyte and does not allow electricity to pass through it, but dissociates in molten, fused or in aqueous solution state. Thus, sodium chloride will conduct electricity only in fused or aqueous solution state. So, let's see this. So NaCl when it is solid, it is non-conductor of electricity. It's a non-conductor, it's a bad conductor of electricity. It's not going to conduct electricity at all, so it will be non-electrolyte in case of a solid state. But when this is in the form of aqueous solution, or it is in the form of a fused state, that is molten state, then it becomes NaCl will form into Na plus Cl minus, and hence it is allowing the electricity to pass through them and becomes a strong electrolyte. So in molten state or fused state, ionic compounds NaCl containing positive charged metallic ions Na plus and negatively charged non-metallic ions Cl minus These ions are not free but held together by strong electrostatic force of attraction. Due to this, an ionic compound in a solid state is a bad conductor of electricity since free ions are essential for conducting electricity. This is exactly what they say, that solid state में we know that NaCl formation कैसे होता है? Na is losing electron, Cl is gaining electrons. So this is Na plus, this Cl minus. Plus and minus, they are going to form a strong bond. So that's the reason that electrovalent bonds are very strong, and due to the strong bond there are no free electrons over there, so the electricity cannot pass through it, because for the passage of electricity it is required that it should be having free electrons. So here, since they are already locked up together, that's why they are going to be not a good conductor at all. So that's why it's a non-electrolyte. But when they come in contact with water, or in an aqueous state, or in the fused state, when they are heated to molten state, at that time the strong electrostatic force of attraction breaks, and that's why this forms into Na plus and this is Cl minus. Okay, even in case of water, when it is added to water having a polar covalent compound, it is of course going to give rise to Na plus and Cl minus. So that's why when an ionic compound is heated strongly, the ions gain kinetic energy and break loose and move freely. The molten solution then becomes a good conductor of electricity. That's what they are shown over here in the figure, that Na plus and Cl minus will have a strong electrostatic force of attraction, but when heated they split into Na plus and Cl minus, forming free ions are formed in the molten state. Similar in the aqueous state. What happens in the aqueous state? When what is a polar covalent compound, polar solvent, and exhibits charge distribution in its molecules. In water, each hydrogen atom develops a slightly positive charge while the oxygen atom develops a slightly negative charge. I explained you this thing when we discussed the chemical bonding. So we know that how a polar covalent bond is formed and how a non-polar covalent bond is formed. So polar covalent bond has got a differential positive charge and negative charge on its two ions. That's why in case of water, you can see the oxygen has got a differential negative charge, where hydrogen has got a differential positive charge. When sodium chloride is dissolved in water, it dissociates into sodium ion and chloride ion, which moves freely in solution. This is due to the fact that the slightly negative charged oxygen atom of the water exerts a pull on the positively charged sodium ion. A similar pull is exerted by a slightly positive charged hydrogen ion atoms of the water on the negative charged chloride ions. Thus, sodium chloride ions become free in solution. So, that is what is going to happen, that this NaCl जो है यहाँ पे, तो water, that is H plus and OH minus over here, they are, sorry, not H plus and OH minus. The water is going to have the positive, H is slightly positive in nature, and oxygen over here is differentially negative. So this differentially negative is going to attract the Na, and this differentially positive is going to attract the chloride over here, and accordingly we will be having this kind of separation of the ions in over here. So that's why the dissociation is going to take place either in the fused state when it is going to be heated like this, or it could be because of the water being a polar solvent that it is going to form into ions. So this is how the dissociation is going to take place in case of NaCl. Now let's understand what is ionization over here. So polar covalent compounds for like ammonia, HCl are non-electrolytes in gaseous state but ionized in aqueous solution state. Hydrogen chloride is an aqueous solution or in a pure liquid state, is unionized and does not conduct an electric current. So we know over here that H plus Cl, so 2H2 plus Cl2 gives you 2HCl. Now this one is a covalent, it's a covalent compound. Okay, hydrogen chloride is a covalent compound, and this hydrogen chloride, when it comes in contact with water, so over here it will be seen that HCl when it comes in contact with water, it is going to give rise to H plus and Cl minus. Okay, it is going to give rise to H plus and Cl minus because of the formation of H3O ions, which is because of the formation of the acid. So what we see over here is hydrogen chloride is, however, polar covalent in nature, shows charge distribution in its molecules such that the hydrogen atom is slightly positive charge and chlorine atom is slightly negative. So in this case it's a polar covalent, so that's why hydrogen atom is slightly positive whereas the chlorine atom is slightly negative. So because chlorine is going to attract the electrons of not only itself but also going to attract the electron of hydrogen. So hydrogen becomes differentially positive. It will be differentially positive and differentially negative will be chlorine. When hydrogen chloride is added to water, a polar solvent, the slightly negative charged oxygen atom of the water exerts an electrostatic pull to the positive charged hydrogen. So this H2O का जो ये है, it is going to be attracted towards the oxygen का. So H2O is also like this. H is differentially positive and O is differentially negative. So this negative is going to be attracted over here, and so the hydrogen chloride is added to water, polar solvent. The slightly negative charge oxygen, Actually, atom of the water exerts the electrostatic pull on the positive charge hydrogen of the HCl. Thus, H plus ion combined with water forming hydronium ion, and the residual chloride ion remains in solution. Hence, ammonia or hydrogen chloride in gas or pure liquid does not conduct electricity, but conduct electricity when dissolved in water. So, you know very well the hydrodynamic of formation के H2O कैसा है, O यहाँ पे, it is like this. So lone pair. So this H over here is going to come over here with the lone pair, forming the H3O and plus Cl minus. So this H3O formation over here is the cause of its acidic content. So that's why this forms into H plus, and so this is how the dissociation, ionization takes place. Over here what has happened? It was neutral, but on presence of, because of the presence of water over here, it got into ions, it became ions. So such a kind of formation of ions is called as ionization. See, this was dissociation. This is connected to dissociation. Dissociation में क्या होता है कि जो चीज ऑलरेडी आयन से बनी है उसको हम लोग स्प्लिट कर रहे हैं. That's why we are just dissociating it. Whereas this is ionization, means जो चीज आयन फॉर्म नहीं था, which was not in the form of ion, and then we are getting it converted into ions, is called as ionization. So that's why we see that on polar covalent HCl, when it reacts with water, it gives you H3O plus Cl minus. So that is the ionization of hydrogen chloride molecules in aqueous solution. Now we have comparison between metallic conductor and electrolytic conductor. Now we normally see that copper, like for example, copper is a good conductor of electricity. Is it an electrolyte? No, it is not an electrolyte. Why? Because in an electrolyte will be the one which is going to dissociate. तो अगर कोई सिर्फ electricity को allow करता है, pass करने के लिए allow करता है, तो it is not an electrolyte. An electrolyte needs to dissociate into two parts. Okay, it is necessary to dissociate into positive ions and negative ions. If I take a metallic conductor, the metallic conductor is made up of only one element. So that's why there won't be any kind of a dissociation taking place in that. It is just allowing the free electrons to move around it, and that's why it is just a good conductor of electricity and not a good electrolyte. So let's see the difference between a metal and an electrolyte. The metal, the flow of electricity takes place by the flow of electrons, which has negligible mass, whereas electrolyte, the flow of electrons takes place by the flow of ions. So it is here, it is the Na plus which is going to move. The Na complete Na is going to move. It is not only the movement of the electrons. The Na plus is going to move. Cl minus is going to move. So that's why these are the ones which are going to be, we can say that they are going to be of heavier masses. Great. So metals flow of electricity is of negligible mass, where the flow of electricity takes place by flow of ions which are denser compared to electrons. Metals, there is no decomposition of the parent metal, and thus the chemical properties of the metals are intact, whereas these are decomposition of electrolytic solution, and thus the chemical properties of the electrolyte are altered. So in case of a metal, they are just going to be the unaltered kind of chemical composition, whereas here of course the chemical composition is altered into ions. Metals are good conductor of electricity in the solid state and in molten state, whereas electrolytes are good conductor of electricity in aqueous solution or in molten state, but not in solid state. Metals during metallic conduction, there is no transfer of matter. The flow of electricity only produces heat energy and no new products are formed. So it is a kind of a physical property, trivial change wherein there is no new substance formed. Whereas here, during the electrolytic conduction, there is a transfer of ions. The flow of electricity decomposes the electrolyte and a new product are formed. So that is the difference between the metals and electrolytes, and hence there is a example given here. Copper metal is thus a good conductor of electricity but is a non-electrolyte since it does not undergo chemical decomposition due to flow of electric current through it. Whereas copper sulfate on the other hand is an electrolyte since it decomposes on passage of electric current from forming copper ions and sulfate ions. The copper ions are discharged at the cathode as Cu metal, and when copper electrodes are used during electrolysis. We'll study that thing in the later part of the chapter, how the copper sulfate dissociates into two parts and what we are going to get at the anode and cathode. Now we have got some experiment. So the aim is to determine whether a given compound of an acid or a salt or a fused aqueous solution is a strong electrolyte or a weak electrolyte. So it's the same thing, simple thing. You have got that electrolytic cell made, and then you are going to, the voltmeter is taken, where X is the electrolytic solution is given compound, Y are the electrodes, so the two electrodes are the Y, positive and negative, anode and cathode. Procedure, the given compound A, acid base or salt, is fused or aqueous state, is replaced in the electrolytic cell and the current is switched on. Observation, the conduction of the electricity through the electrolyte is indicated by the glow of the bulb. So we are not seeing what is going to happen at the anode and what is going to happen at the cathode. We are just trying to understand that whether it is going to be electrolysis is taking place or not taking place. How do I understand that? By the glow of the bulb. So we see if the given compound A, that is acid, base or salt solution, is a strong electrolyte, the bulb glows brightly when the current is switched on. So when the current is switched on, if the glow of the bulb is bright, then we consider that the electrolyte which is used is a strong electrolyte. If the given compound A is a weak electrolyte, the glow of the bulb will be dim. So if it is a dim kind of a bulb glowing, then it is a weak electrolyte which is there when the current is switched on. So it will be a weak electrolyte if there is a dim light, and there is no light, then it is a non-electrolyte. So thus different acids, base and salt solutions can be classified into strong weak electrolytes based on the glow on the thing. So we see acids, base and salts. Acid, base and salts are dissolved in water or in fused state, dissociate into free mobile ions, and can be classified as strong or weak electrolytes depending on the degree of dissociation. So strong electrolyte, compounds which in a diffuse or aqueous solution state are almost completely dissociated, are good conductors of electricity, are called as strong electrolytes. So those aqueous solutions or fused conditions के जो भी compounds है, if they are able to dissociate completely and are good conductors, then they are called as strong electrolytes. Whereas compounds which in the fused or aqueous solution state are feebly or partially dissociated and are poor conductors of electricity are called as weak electrolytes. So that is how we are differentiating between strong electrolyte and weak electrolyte depending upon the dissociation which is taking place, whether it's a complete dissociation or partial dissociation. If it's a complete dissociation, it's a strong electrolyte. If it is a partial dissociation, it's a weak electrolyte. So yeah, good conductor, strong electrolyte. Bad conductor with electricity, weak electrolyte. Not bad, but poor conductor. Bad to non-electrolyte ho jayega. So accordingly, we can classify the acid and base into strong and weak electrolytes as follows. So acid, mineral acids ionize to dissociate into water, furnish H plus in solution. So strong electrolyte like HCl will be H plus and Cl minus. Nitric acid will be H plus and NO3 minus. Sulfuric acid will be H plus and SO4 2 minus. These all will be strong electrolytes because they are the one which are going to be dissociating completely. Okay, any particular acid which is going to dissociate completely without any formation of any molecules with it, they will be called as the strong electrolyte. Whereas in case of acetic acid, it will be CH3COO and H plus. Formic acid will be CHOO and H plus. And carbonic acid will be H plus and CO3 minus. So these are the weak form because they will be not dissociating completely. So those acids which do not dissociate completely are the weak acids, or not the weak acid, they are the weak electrolytes, whereas the one which completely dissociates are the strong electrolytes. Similarly for the bases ionize in fused or in aqueous solution state furnish OH ions. So here the main thing what is going to be the OH ions. So in case of acid it was H plus ions, whereas in bases will be OH ions. So for example, potassium hydroxide H plus and OH minus, strong electrolyte. NaOH, Na plus and OH minus, again strong electrolyte. Lithium ion hydroxide will be Li plus and OH minus, will be again a strong electrolyte. So electrolytes which are going to, these are the one which are going to dissociate completely into OH ions and the metal ions. Whereas calcium hydroxide Ca plus and OH minus, or magnesium hydroxide Mg2 plus and OH minus, and ammonium hydroxide NH4 plus and OH minus, these are going to dissociate partially. So because they are not going to dissociate completely, hence they are called as the weak electrolytes. So the calcium, magnesium, ammonium hydroxides are going to be weak electrolytes, whereas the sodium, potassium, lithium are going to be called as the strong electrolytes. Salts, ionic salts ionize in fused or in aqueous solution state, so furnish positive ions other than H plus and negative ions other than OH minus. So when we are talking about salts, we know that salt is going to be a combination of a metal and a non-metal. So when you are taking a salt which is made up of a metal and non-metal, we have to see that it is not forming the metallic ion, that is plus or positive ions should not be hydrogen, because otherwise we are talking about acids, and the non-metallic ion should not be OH, otherwise we are talking about bases. So that's why if the positive ion is not hydrogen and anything else, and the negative ion is not OH and anything else, then those particular salts will be the one which will be furnishing the ionic salts, or called as ionic salts. So if it is a strong electrolyte, then it will be PbBr2 will be Pb2 plus and Br1 minus molten state. CuCl2, Cu plus and Cl minus, AgNO3, Ag plus and NO3 minus. All these are strong electrolytes. So lead bromide, copper chloride and silver nitrate are strong electrolytes. Whereas sodium carbonate, so carbonate over there is a weak electrolyte. So forming the carbonate is not going to dissociate completely, hence it will be Na plus and CO3 minus. Bicarbonate also, potassium bicarbonate H plus, K plus and HCO3 minus. And similarly acetic lead acetate with this CH3COO minus and Pb2 plus will be again a weak electrolyte. So that's why this is how we are differentiating the strong electrolyte in case of acid, base and salts, and weak electrolytes in acid, bases and salts. So these are examples of strong and weak electrolytes in acid, bases and salts. We now see the next part of the chapter, that is the electrochemical series. I told you earlier that they are similar to the electrolytic there is the reactivity series in case of metals. There is also a electrochemical series in case of electrolysis. So electrolysis के लिए they have made a electrochemical series. Now electrochemical series is quite similar to the we have got electrochemical series is there for anions as well as cations, but the reactivity series is only for the metals. So that's the only main difference between the two. But yeah, it is seen that normally when we talk about the cations or the metals, the electrochemical series and the metallic reactivity series is almost the same. There's a very small difference between the two. So depending on the ease with which the metal lose their electrons and form ions, they are arranged in series known as metal activity series or electrochemical series. So the electrochemical series tells us that how easy it is to get that particular ion dissociated in a particular. So when you see that the electrochemical series is such that the one at the top will be difficult to get and one at the bottom are easy to get. So depending upon the ease of the discharge, okay, ease of discharge or increasing ease of reduction or increasing ease of getting it at the cathode is given by the electrochemical series of cations. Similarly, there is electrochemical series of anions which will be giving you the ease of discharge of these anions at the anode. So at the top of the series, so the arrangement is done that the elements that ionize most readily discharge with great difficulty. So the one which get ionized easily, the one which can lose electron and gain electron very easily are the ones which are going to be difficult to be discharged. Okay, the ones which are going to be difficult to discharge are the ones which are going to get ionized easily. So the arrangement is so done that the element that ionize most readily discharge with great difficulty are placed at the top of the series and other elements in the descending order. At the top of the series, metals which ionize most readily are included at the top of the series. Metal lose electrons most easily, so positive ions, for example K, potassium is the most easily one which can give away its electron very easily. So K gives away electron and becomes K plus, so that will be the topmost of the list. Positive ions, cations formed are discharged at cathode with most difficulty. So cations gain electrons with greatest difficulty. So neutral atom K plus 1 electron give you electron. It's very easy because the tendency of the potassium is to give away electrons. So when it is going near the cathode to gain an electron, it is the most difficult thing for the potassium to do. See, potassium will be one which is always donating electrons. उसको अगर बोलेगा नहीं तो एक इलेक्ट्रॉन ले और अपने आप को न्यूट्रल बना, तो that is going to be the most difficult thing for it to do. So that's why it is considered to be as the most difficult thing to be achieved in a discharge in electrolysis. So that's why metals which are positive ions are going to cations which are going to be gaining electrons to form into neutral atoms is going to be difficult for potassium. So cations gain electrons with the greatest difficulty and form neutral atoms. At the lower end of the series, so at the top is of course those ones which are going to be easily giving out the electrons but very difficult to gain electrons. So these are the ones at the top of the one. Whereas the lower part of the series में कौन से है? तो metals which ionize least easily, okay? So they take some time to lose their electrons. So the ones which are those metals which are going to not be easily giving away their electrons, so they ionize least readily are included in the lower end of the series. Metal lose electrons to great difficulty to form positive ions such as Cu and Ag, and that is oxidation is going to take place. And when these positive ions form are discharged at the cathode, most readily, because these are the ones which are going to, because there is a difficulty in them giving away electrons, so at the same time it will be easy for them to take electrons from the cathode, and hence cations gain electrons more easily and form neutral ions for copper and silver. So Cu and Ag will be at the bottom of this particular table because they can easily get form into a neutral atom. So we see that metals it will be K will be at the topmost point, K CaNaMg, AlZn FePb, HCu Hg Ag. So these are the things that it is potassium, calcium, sodium, magnesium, aluminium, zinc, ferrous, lead, hydrogen, copper, mercury and silver. This is how it is. So discharged with most difficulty are the topmost one, and positive ions, cations discharged at cathode by gaining electrons. The tendency of the cation to get reduced at the cathode increases on descending the electrochemical series. Discharged most easily at the bottom. So last one are the most easily discharged over here. Similarly, the anions are SO4. The sulfate will be the most difficult to get discharged. Nitrates will be the next, chlorides, bromides, iodides will be the next one, and easiest to be removed is OH. OH will be the discharge most easily, whereas sulfate will be the discharge more difficult. So negative ions discharge at anode by loss of electrons. The tendency of the ion to get oxidized at the anode increases on descending the electrochemical series. So that's why you will find that it will be this way, that the one at the top of the electrochemical series will be difficult to get at the electrode, whereas the one at the bottom of the electrochemical series will be easy to get discharged at the electrode. So that was about the electrochemical series. We now move on to the selective discharge of ions in the next video.